I'm going to solve this system of two equations using the addition method. And when I add both equations together, I want one of my variables to eliminate, to cancel out. And you can see that if I tried to add them right now, neither one of my variables would eliminate. 10x plus 5x would be 15x. That does not cancel out. Negative 14y plus negative 7 is negative 21y. That does not cancel out either. Okay, so I need to change one or two of these equations and get one of my variables to cancel out. Now, I can use the x's or the y's. It doesn't matter. I'm going to choose the x's. And if this is 10, my least common multiple between 5 and 10 is going to be 10, right? I could go up to 20 or 30 if I wanted to, but I'm going to leave it at 10. So I want to change this to make it look like 10. I'd have to double it. And since this one is positive, I want the opposite so they cancel. So I want this to be a negative 10x, and then that way they would cancel out. In order to get that, I'm going to multiply this equation, every term through, by negative 2. All right, so let's move this system over. My top equation is going to stay exactly the same. And my bottom equation now is going to be negative 2 times 5x is negative 10x. Negative 2 times negative 7y. Negative times a negative, positive 14y. And then negative 2 times 7 is negative 14. And now you see that when I add these together using the addition method, that my x's will cancel out. 10x minus 10x is going to be 0. Negative 14y plus 14y also cancels out to give me a 0. And then 17 plus negative 14 is 3. Okay, this is one of those cases where all of my variables cancel out. So the answer is either going to be no solution, because the lines are parallel, or infinitely many solutions because the lines are right on top of each other and they coincide. So let's see if we have a true statement or a false statement. 0 plus 0 is 0. Does 0 equal 3? No. 0 does not equal 3. So this is a false statement, which means that these lines are parallel. And what points do they share? Well, they share none. They will never cross. They'll never touch. They'll never cross. They'll keep going on forever and ever and ever, and they will never share a point. So we say that the answer to this is empty set. Okay, there is no solution. You may also see it as no solution. All right, the set of nothing or no solution. Now, they also call parallel lines inconsistent. Okay, so you may see that also. It may ask you inconsistent, right? If they were right on top of each other, they would call that dependent. If they were if the lines coincided, but since these lines don't touch, they are inconsistent. So my answer here is empty set, and the lines are inconsistent.